Okay, this is the lesson for section 8-7, which is on vectors. So you've already used trigonometry to find side lengths and angle measures of right triangles. Now you're going to find magnitudes and directions of vectors, and you're going to add and subtract vectors. You may have already heard about vectors in your science class. So lots of new vocabulary. What is a vector? What's standard position? Component form? Magnitude? Direction? Resultant vector? Parallelogram method, which I think I might avoid, and the triangle method, which I prefer. So there's a great website that really shows you what vectors are. So it's listed on this page. And we're going to use the website to answer the questions about components of a vector. So how do the numbers for direction and magnitude correspond to the appearance of a vector? So this is a vector investigation of taking the boat to the island. So what you notice here is this is what a vector looks like. It almost looks like a ray, except it has a starting point, but it also has a stopping point where a ray never ends. So when I look at these two vectors, this blue vector has a magnitude of 15. The direction is 212.1. The red vector has a magnitude of 9.5, and it has a direction of 164.57. So when I move these, I can see that, of course, changing where the arrow points is changing my direction, for sure. And when I shorten the vector, the magnitude's of 4, so I make the vector longer, then I get up to a magnitude of 15. So the length of the vector deals with the magnitude. The direction that the vector is going is actually a measurement of a degrees in angle. This application does the direction a little bit differently than I do. Okay? They say that straight up is 0, and to me, I'm going to teach you on the coordinate system and quadrants. This would be a 0 direction on the coordinate plane. Okay? So what you get out of this is that vectors have two components. They have a magnitude and they have a direction. And the magnitude is actually the length of the vector, and the direction is the degrees of the angle. So the second question is, how do those numbers correspond to the movement of the boat? So I'm going to shorten the boat vector up, where its magnitude is only a 3, and its direction is 164.51. So when I hit start, that causes the boat to move in the exact same direction that the vector is pointing. So when I change the length of the vector, let's make it longer. So now it's as long as I can make it, and I hit start. Notice how much faster the boat's going. So that's what the length of the vector is doing. It's controlling the speed of the boat. There it's kind of slow. The longer I make that vector, the faster the boat goes. The red vector is controlling the current of the water. So when I move the red vector, you can see the water change direction. So if I make the water go against the boat, that pushes the boat back because the water's going faster than the boat. Because the water was going with a magnitude of 8.8, and the boat was only going 2.3, so that's why the boat got pushed backwards. So in this case, the magnitude of the vector controls the speed of the boat, and the direction of the vector is controlling the direction of the boat. And the last question asks, what happens when you move the vector into a new position using its midpoint? So I'm going to move the boat. There's my vector causing the boat, and the current's actually pushing the boat. So now I'm going to reset this, and I'm going to move where the vector is. What effect did that have on the movement of the boat? Absolutely nothing. So the positioning of the vectors means nothing to the direction or the speed of the boat. The vectors can be moved anywhere, and you're going to get the same result every single time. So you should come to further see that the position of the vector on the screen is of no importance. Dragging it around by its midpoint does not change the speed or the direction of the boat. The relevant features of a vector are its length, which is its magnitude, and its direction, which is the degrees of the angle. And if I adjusted the length of the vector to 0, and I hit start, the boat wouldn't move. So if I change, I'm going to reset this. I'm going to move the vector to 0, which is very hard to do. Let's try this again. I'm just going to come over here and change the magnitude to a 0. And now when I hit start, the only thing that's moving is the current. So because the current moved, that's why the boat moved. So if I change the magnitude of the water to be 0 as well, and I hit start, then of course nothing's moving. Okay, because 0 miles per hour, the boat's not going to move. So just to recap, a vector is a quantity that has both magnitude and direction. The magnitude of a vector is the length of the vector from its initial point, so where it starts, to its terminal point, which is where it ends. The direction of a vector is the angle that is formed with the positive x-axis or any other horizontal line. That's the only thing I didn't like about that applet with the boat, is that the angles don't match up with the coordinate plane. So you say that the magnitude of vector AB has to be absolute value because it's the speed of something. So the speed of something would always be positive. You never go like a negative 5 miles per hour. So that's why it's in absolute values. The direction of vector AB is how many degrees the angle makes with the horizontal line. So just a note here, what's the notation for a vector? It's half of an arrowhead. So you know a ray, if I had ray AB, it would be a line with a single arrowhead. Well, vector AB is like a line with half of an arrowhead. So that is the difference between the notation for a ray and the notation for a vector. So vectors can be represented as directed line segments. So they're actually a segment, not a ray, because they have a starting point and a stopping point. The vector shown, which can be called vector AB or vector V, because it starts at A, it ends at B, so I can call it vector AB, or you can name it with a single letter, just like with a V. That vector has an initial point A and a terminal point B. Now, when you place a vector on the coordinate plane, it's in standard position when its initial point's at the origin, so it starts at 0, 0. So both of these vectors, vector V and vector W, are in standard position on these coordinate planes. The component form of a vector is described in terms of its horizontal change x and its vertical change y from its initial point to its terminal point. So the component form of vector W is x, comma, y. Notice that these are not parentheses. Okay, these are angled. That's what indicates that's the representation of a vector. Okay, so that's the component form of a vector. You should notice that horizontal change in x and vertical change in y should sound very familiar. That sure sounds like slope. So it's like rise and run. Okay, it's your rise and your run from the beginning of the vector to the end of the vector. But we don't write it as a ratio like we do for slope. It's rise over run. We write it as an ordered pair, horizontal change, comma, vertical change. Then you're going to write vectors in component form. So you're going to write the component form of vector AB. Well, my initial point is A, my terminal point is B. That does matter. You're going to have to identify those. So if I want component form, really all I have to do is slide this vector to where the initial point starts at 0, 0. So on a graph, this is what it would look like. If this is my vector, I just grab the vector, slide it so that it starts at the origin at 0, 0. So then the end point of the vector is going to be the component form, so that ordered pair. So the ordered pair is -4, comma 3, but we don't use parentheses to do a vector. You have to use the angled brackets. So that's what the answer is going to be -4, 3. So the question is, how do I get the answer -4, 3 without having to do a graph? Well, That negative 4, 3 actually came from the rise and the run of the vector. It's like doing slope. So the only difference is the order you subtract matters. You have to do terminal point minus initial point. And instead of writing it as a ratio with y's over x's, you write it as run, comma, rise. And that would be your component form. So if I want to get the run, I start with point B because that's my terminal point. And I subtract my x's. So negative 5 minus a negative 1. And then to get my rise, I start with point B. So I'm going to do negative 1 minus a negative 4. So then this is actually negative 5 plus 1, which is negative 4. And this is negative 1 plus 4, which is a positive 3. So the component form is negative 4 comma 3 with vector notation. So pay careful attention that you're doing the correct kind of symbol for a vector. For example 2, you're to find the magnitude and the direction of vector ST for the ordered pairs S at negative 3, negative 2, and T at 4, negative 7. So magnitude is just the length of the vector. So all you have to do is the distance formula. So if you forgot the distance formula, there it is. So you're just subtracting the x's and subtracting the y's. The only thing I would caution you about, and it's really not going to make a difference, but in vectors, get in the habit of starting with the terminal point first. So label your terminal point as your x2, y2. So t was the terminal point because it came last in the name of the vector. So when you go to do this, I would subtract the x's, so I would do 4 minus negative 3 squared.